All right, so the leading term of a polynomial turns out to be very important in determining the long-run behavior of a polynomial. So sometimes we're given a function that it is a polynomial, it's just not written in an expanded form, and we want to know the leading term. All right. Now, the other thing with this one, I can see, ugh, I don't want to have to, I don't want to have to cube this all out. It's a lot of work to actually, cube this all out. I mean, this one is to the fourth power, so this is really, 2x to the 6th minus 1 times 2x to the 6th minus 1 times 2x to the 6th minus 1, 4 times, right? So I don't necessarily want to have to, do all that work just to find the leading term. All right, so if I just wanted the leading term, let's take a look at this though, as if we were going to expand this all out. So that first one, right, this is 3x to the 5th plus 2 times 3x to the 5th plus 2 times 3x to the 5th plus 2. So I'm going to square one of these, right, and I'll end up with 9x to the 10th, right, that's the first term squared. The middle term is first times last times 2, so I'm going to end up with 12x to the 5th. And then the last term is going to be 2 squared, which is 4, right? So I just am squaring it. And so this is the same thing, right? This is, I've just broken off I've put two of them together. I've squared two of the factors of 3x to the 5th plus 2, all right? Over here, I could treat this like 2x to the 6th minus 1 squared, and I could write this if I wanted, because squaring things isn't too bad, right? So I could write this as 4x to the 12th. I'm just going to square this thing. And then first times last times 2 gives me a minus 4x to the 6th. And then the last term squared is a plus 1. And then I'm going to take it times itself, right? Because I've got the fourth power. So I think I can see I'm running out of room here. Let me see if I can, I don't know if I can, no, it's not going to let me. All right, 4x to the 12th minus 4x and then a plus 1. I'll just write it like that. All right, you can see that I've squared two of the factors of 2x to the 6th minus 1. And, okay, I could keep going and I could expand it all out. But what I want you to see is that if I was going to take the next step and I was going to take this 3x to the 5th plus 2, and I would have to distribute it and take that times each one of the terms in the second factor, right? I need to take all of this and multiply it by each one of these terms in the second factor. All right, but all I really care about is the leading term, so I don't really want to do all of that. I'm just going to multiply the 2 with the highest powers of x, right? So if I take 3x to the 5th times 9x to the 10th, I end up with 27x to the 15th, right? And plus a bunch of other stuff, which I don't care about. I only care about the highest. I'm just trying to find the leading term, right? All right, and I can do the same thing over here, right? If I really wanted to work all this out, I'd have to take this whole thing times each one of the terms in the second factor, right, and distribute it. But I only care about the leading term. The leading term, the one with the highest power over here, is going to be 4x to the 12th times 4x to the 12th, which is going to be 16x to the 24th, and then plus a bunch of other stuff that's going to be, the power of x is going to be lower. All right, so now I have to decide, okay, which one of these is the leading term, right? So obviously this one has the higher power of x, so that means that 16x to the 24th is the leading term. All right, so what I was trying to demonstrate here is that you don't have to go through all of the work to expand that expression if you're just interested in what is the leading term. Okay, so that's kind of a shortcut way to do that. What I would probably do if I was trying to demonstrate this to you, but what I would probably do instead is just look at, I would, if I was, if I was actually doing this myself, I'd look at the 3x to the 5th, and it's to the 3rd power, which is going to make it this 27x to the 15th, right? And if I take 2x to the 6th to the 4th power, that's going to give me the leading term of the second part of this expression. And so I get the 16x to the 24th, right? That is 2x to the 6th, the whole thing to the 4th power. All right, so then you can save yourself some work and not have to like expand everything out. All right, well, I will meet you in the next video for the next example.